Welcome. Today is April 30th, 2019, and this is the NHERI SimCenter's Advances in Computational Modeling and Simulation webinar. Today we are introducing the SimCenter's performance-based engineering application, a cloud-enabled desktop application that provides estimates of decision variables to help quantify the performance of a building. Today's introduction will focus on the seismic hazard capabilities of this application. And this webinar is coordinated by the Natural Hazards Engineering Research Infrastructure's Computational Modeling and Simulation Center, also known as the NHERI SimCenter. This webinar is supported by the National Science Foundation under awards 1612843 and 1520817. Any statements in this webinar are those of the presenter and do not necessarily represent the views of the National Science Foundation. Speaking of our presenter, we are joined by Adam Jarnotzai, a SimCenter postdoctoral researcher at Stanford University, where he is implementing tools for uncertainty quantification and performance-based engineering for natural hazards. His research is in probabilistic seismic hazard and seismic performance assessment, seismic design, and numerical modeling of buckling restrained braced frames, and quantification of model uncertainty in earthquake engineering. The title of his presentation is Earthquake Damage and Loss Assessment with SimCenter's PBE Application. Adam, thank you for joining us, and I'll hand this over to you now.
Thank you, Matt. Hello, everyone. Thank you very much for joining me for this 1-hour webinar. I will try to speak around 40 minutes, 45 minutes, and I will leave about 15 minutes for questions. So please save your questions for the end and make sure you send them to the moderator and he will relay them to me. That's an interesting start. Oh, that was the very end of the presentation. Nice. Okay, so let me start again here. So, you already heard this disclaimer. I am not going to read that again, and let me jump immediately to the outline. I will start with an overview of the SimCenter because I think my experience is that there's quite a bit of confusion about what the SimCenter is and what do we do. So I would like to spend a couple minutes on explaining that to you, and then I will introduce the PBE application, and we will follow that with a hands-on demo. That will be the majority of the webinar. And as I mentioned before, we will end with some questions and hopefully some answers. So what is the SimCenter? The SimCenter is one of the NHERI facilities supported by NSF. You can see the NHERI facilities on this slide. There are quite a few of them. And my experience is that the SimCenter is often confused with design safe. So I would like to state that very clearly, that SimCenter is not design safe. It's not part of design safe, but rather a similar facility like design safe, and we are working with design safe to help the research community. Design safe provides the cyber infrastructure, and we are providing the workflows that use that cyber infrastructure and give you interesting results to complex calculations and to solve complex problems. So our mission, and you will see these 2-line or 3-line statements at the top of the following slides that might be difficult to comprehend, so I will try to unpack them. So our mission is to transform the nation's ability to understand and mitigate adverse effects of natural hazards on the built environment through computational simulations. So what that really means is that, as I mentioned before, we are working with the design safe cyber infrastructure, and we are developing an application framework. I will talk about that in a second. And we are providing you access to that framework and the workflows that we build from that framework through research applications. You can see that here. So these 4 are our research applications, and one of them is PBE that I am going to talk about today. And PBE is really just a facade, a front end that provides you access to this workflow that we built and provides you this potential to run complex simulations on high-performance computing clusters in the cloud. And besides these applications, we have some other tools that we develop, as I will show you later. But the main purpose of our existence is to create these applications and make it easy for the research community run complex calculations at supercomputers. These are the three main products that we develop. I call them products, but that doesn't mean that they cost money. So these are all free. Application framework, as I mentioned, is the most important thing that we are working on. And we have this jigsaw here because we imagine this application framework as a system of interconnected applications that can kind of talk to each other through the interfaces that we develop between them. And this allows you to design various workflows in a very modular fashion. So if we put together a workflow and there is an application that you don't like, you can create your own jigsaw piece and you plug it in there, say for response estimation. We use OpenSeas now, but if you don't like OpenSeas, you want to use something else, you can wrap it in your own code and plug it in there. And then you can keep working with in a familiar environment and have access to all the other tools that are available in our framework. And besides these applications, we also pay a lot of attention to the data that supports them and making sure that you can connect to those databases that are available for the research community. And uncertainty quantification is in every step. So this is it in a nutshell. And when we have such an application framework, we can create various workflows. And one of our most ambitious undertaking is the regional hazard workflow, which if you look at today's presentation, you might get the impression that this is actually a regional earthquake workflow, but that's only because at the moment, this is where we are. We have a seismic performance assessment ready, but that doesn't mean that we are going to stop here. So we make steady progress, and by the end of the year, we want to have a regional workflow for hurricanes and hurricane-related damage as well. So as you can see, this is color-coded on the right side so that you can see which puzzle piece goes to which step of the workflow. You can see that using that puzzle, we can put together this workflow pretty nicely. And then this would allow you to do all those regional hazard and damage and loss assessments. But the problem is that this is still fairly difficult to use because it would be an interconnected network of applications. So here comes the third thing that we develop are these desktop applications. And one of them is PBE here, which what really does is it takes a piece of the workflow out. So you can see that it's kind of this middle piece, and then it makes it much easier for you to access it and use it and get used to it. And then once you get familiar with it, you can probably leave the user interface and the desktop application behind and start using the full workflow. But this is a very nice learning process, and it allows you to get familiar with what we are doing and how these applications and workflows are designed. So just to give you an example of what applications and what different puzzle pieces can go together, here is an earthquake simulation workflow with 3 different types of fidelity. So in one case, you can think about HAZUS style loss assessment and the corresponding very simple modeling of the structural response. And if you don't like that, you can simply switch this piece and you can have a high fidelity model and a FEMA P58 style, more detailed loss assessment. Similarly, on the hazard side, you can start with a seismic hazard analysis, but you can also have a physics-based seismic wave propagation calculation, and then you have the ground motions from there. So this one is a probabilistic procedure based on historical data, and this one is more physics-based, based on the understanding of the soil conditions around the site. And we could continue with different other options. So this is how we imagine having multiple choices available for the researchers so that they can, or you can, put together the workflow that fits your needs and your particular objectives. And whatever you put together, we pay very much attention to make sure that you can run it locally so that you don't necessarily have to share your early results or your first pieces of code or new developments. But then you can also run it in the cloud through DesignSafe without making any changes to your code or your input files. So once it runs locally, it will run on DesignSafe too. And we think this is quite powerful. One example, or two examples actually, of the workflows that we put together and the potential that is already there are demonstrated by the test beds that we have. We have one test bed for the San Francisco Bay Area. You can see an example here with the expected damage from a magnitude 7 earthquake at the Hayward Fault. And we also have another test bed that we put together last November after the earthquake in Alaska, just to show that this approach and having these tools available to you would allow rapid assessment of the damage and the losses after such an event. And both of these were significantly less amount of man-hours to put together than if we had to start from scratch. So if you are interested in earthquake losses in the United States, it's usually quite easy to get the data that is required. I mean, building information, for example, and then you can do a similar kind of assessment within a reasonable amount of time. After the workflows, let's see a little bit about the applications, the other applications besides PBE. So PBE is here. We build research and educational applications as well. So I already talked about the research applications that are basically parts of this larger regional workflow, and then we put a facade in front of that calculation backend so that you can access it easily. We have the EEUQ, which was presented last week by Frank McKenna. CWE is more about wind-related calculations, and UQFEM is an application that focuses on uncertainty quantification for finite element modeling. And besides these, so these are for research, and we have 4 applications that are more focused on education. So these are usually simpler applications. They don't use the regional workflow, but they use tools that we identified as interesting or important for students, and we allow them to access those tools and to run some interesting calculations and interesting problems for educational purposes. You can see these applications and you can read more about them at our website. This is a screenshot of our website. You can see the research tools under research tools, and you can see the educational applications under learning tools. So finally, this is the final slide about what the SimCenter is, and I believe this is very important. So our main goal or main objective is to build a community or help building a community around research in natural hazards. And we do this by helping people to share their work and share their results and methods. And this makes everybody work together towards the same goal. That's how we would like to see it. So it's very important to understand that SimCenter very rarely develops applications or tools for a particular purpose. There are exceptions, and I will show some today. But mostly we are searching in the community and trying to identify the tools that are already available. And we just package them, make a jigsaw piece, and then make it available to others so that you all can use the tools that others have already made. And this avoids developing the same thing twice or 3 times as it happened already in the past few decades. So that's enough about SimCenter. And then now let's see a couple of slides about the PBE application. So you might remember this figure. I've shown it just a few slides ago. We have this application framework that we build, and now using that framework, we put together a regional hazard workflow, as you can see here. And then one of the desktop applications that access part of that workflow is the PBE application. So one limitation here that you can immediately see is that it will not be able to do performance-based engineering at a regional level. So what we are looking at is an application that will assess or help you assess the performance of a building. If you want to go beyond a single building, you will have to use our regional hazard workflow. If you are interested in that, you will find more information about that at the website. But it's important to know that even that workflow uses the same backend for the performance assessment as the PBE application. So if you get familiar with the backend and if you get familiar with the performance assessment in the PBE application, it will be much easier to use our regional workflow later. So here are a few details about the application. As I mentioned, it's mainly a front end. So it has this front end part, which is really a desktop application. It runs on 3 different platforms. It runs on Macintosh, it runs on Unix and on Windows platforms. And it provides this convenient user interface to this part of the workflow, this script of the workflow. And you might notice that everything except this red part is actually something you already heard about if you were there last week at the EEUQ webinar, because this is just a response estimation considering uncertainty in the event and uncertainty about the characteristics of the building. So that is covered by EEUQ. And then what PBE does is it extends the EEUQ backend so that you can assess the losses given the response of the building to a seismic event. And the desktop application part, so what you will see in today's webinar is a front end that prepares an input file for this backend that does the calculation. Now, one consequence of this is that once you are very familiar with how that input file looks like, you will be able to create that input file yourself using your own, I don't know, MATLAB code or a Python code or whatever you use for your own research. And then you will not need the desktop application part, and you can use the backend independently. So what we envision is that we provide you options to grow beyond being a simple user who just clicks through this application. But we really recommend to start clicking through, and then you will see how it works, and then you will feel when you are ready to run the workflow, the backend, without the user interface, if that's what you like to do. The damage and loss assessment, that's also important to note before we go into the details, is performed using a Python library. We call it Pelican, and you can find it on GitHub. I will also show it a little bit later. And this is a Python library that is free to use, and it allows you to perform this damage and loss assessment based on building response using either FEMA P58 methodology or the HAZUS methodology at the moment. This is the core calculation engine right now behind PBE, but with everything else, even with loss assessment, we try to be modular. So if we find an application that is free and that works on every platform, we are very happy to include it in the PBE tool as another option besides Pelican. So we don't want to be exclusive here, but we have yet to find any application that would fulfill that purpose. Finally, the workflow is meant to be hazard agnostic. So we start with earthquakes, that's what's available now, but we are working hard on making hurricane wind caused damage and losses available in the PBE app. And that would mean that you will be able to calculate such losses for a single building using the PBE application, and then once you learn how that works, you can go to the regional level and you can calculate hurricane losses there as well. And then in 2021, we plan to have storm surge and tsunami as well. So we are quite ambitious with our plans, and we hope that this will allow people to see the synergies between between the performance assessment for different hazards, and possibly, hopefully, share their experience between these disciplines and be able to learn from each other. Now, I will have a slide that shows something that Frank showed last week for the EEUQ. So as you can see, all of these options are available in EEUQ for the different puzzle pieces in the workflow. So you have different ways to model the structure, many different options to model the seismic event. We have OpenSeas for finite element modeling, and we use Dakota for uncertainty quantification. And then EEUQ provides EDP values in the end. And what we do with the PBE tool is that we pick up from here, and then we use Pelican to calculate the decision variables that describe the damage, that describe the losses, and the damage measures that describe the damage in the building. So one more thing before we start the demo. I really recommend you to read the manual, because it will help you install the environment that is required to run the application. It's not very challenging, but if you don't read the manual, I think you will have a hard time. So it walks you through it, and then it will explain the usage of the tool, every single panel, every single field that you can use to define your problem. And it also has some troubleshooting parts where we try to find and try to identify the typical errors and help you to solve those problems. And if you cannot find a solution for your problem and you are experiencing errors, that could very well be because there are bugs in the software. It would be a lie if I told you that it's a perfect tool. Of course, we have certain issues, and we would be very happy if you told us if you experience problems, because that helps us correct those problems and helps us go and move forward. So please give us feedback if you experience trouble. Okay, so now comes the demo. I will start with showing you our website. So you can see this is simcenter.designsafeci.org, and I will show you how to get the application. I'm not going to wait for the download and do all that stuff, but just to show you that you go here, Research Tools, PBE Application, and then you have a download link here. So you click on that, and this is a data depot. And here you can see different versions, but don't click on those. We will always find the latest versions listed here. This is for Macintosh and this is for Windows. So you just download these files and extract them, and then you can run the application from there. You will also find the documentation here. There's another link outside to that. So I really recommend you to download that and follow what it suggests. Let me show you what you get when you download the documentation. So this is how it looks like, and it starts with these installation instructions. And so if you are planning to run your work at a remote supercomputer, you don't need to install a lot of things. All you need is Python on your computer. But if you want to run the calculations locally, you will also need to install a couple of other tools like OpenSeas for the finite element calculations, and Dakota for uncertainty quantification. And we explain how to do that here. We also give you suggestions on how to test your installations. So everything you need to install, you can test, and if the tests don't work, then we can help you to find the problem. So you see, you run these tests, and then you have the application ready, and it should work. And then we also explain how you can test the application itself. So you install the environment, you have Dakota, you have OpenSeas, you have all those stuff. And then how can you make sure that you will be able to do a calculation with this PBE application? And I will start with running that test here, because it's just very quick, and it will allow me to walk you through the interface, and then we will gradually advance to more complex examples from there. So I have just started this application. This is how it will look like for you. And seeing the interface doesn't mean that you will be able to do a proper calculation with it. So don't be fooled by that, because as I mentioned, this is just a facade. It will create an input file. It will give it to the workflow backend. And then if there is a problem with one of your tools that we use, so say you don't install OpenSeas correctly, then it will only realize that when it tries to run the finite element analysis, right? So seeing this doesn't mean that everything is going to be okay. Now, as we explain here, you don't need to set a lot of things to put together an analysis really quickly. So as you will see, we only need to change a few fields, and then we will be able to run a calculation. So what we do here is we give it a name. This is not necessary, but just it's good practice. And then we give it a location. I will use Stanford, and I think it's, yeah. So pay attention to the units here. We will keep the US units for now. And then in the second tab, we could set up a model. We could set up various kinds of models, but we will leave it as it is, and this will give us a nice single degree of freedom system. So we don't need to touch that. And then for the event, instead of loading a ground motion or doing seismic hazard assessment, we just use a stochastic ground motion tool that will generate a time history for us. Frank also explained this last week, so I'm using the same example that he used then, where I say that it's a 6.5 magnitude event, 20 kilometers from the site, and the VS30, so the soil stiffness, is going to be a random parameter in our calculation. So this is it. We have an event, and then here we could set some parameters for the analysis, but we are not going to do that now. And we use Latin hypercube sampling. So this is the uncertainty quantification tab. Latin hypercube sampling, 10 samples. And as you can see, it already picked up our random parameter VS30. And I'm also following Frank here from last week. So I'm adding a 350 for the mean and 25 for standard deviation of the VS30 normal distribution. It doesn't really matter because we are just running a test now. And for the damage and loss, we are not going to use the FEMA P58 now because it's more complicated. We are using HAZUS, and we are reducing the number of realizations so that it runs quickly, and just make sure that we provide some data here. So we say it's a residential building with 10 people, and we give it a value of $1 million, right? That's a million. And we say that it will take 500 days to repair. All right, that's all you need. And we should be able to run this right now. So we just set up a single degree of freedom system with a stochastic ground motion, VS30 being uncertain, and a HAZUS style assessment so that we assess the damage and the losses in the whole building with assembly-based fragilities and consequences. What you do now is that you click run, and this will be populated automatically. So this one is your is the folder where you put PBE. I just put it in the PBE webinar now. And this one is in your documents folder on your computer. And I will replace this now. You shouldn't do that. I will replace it because I want to show you some of the results, and I want to make sure that they are going to be available. So if you specify a workdir here, it will put all the temporary files in that directory. So I just put it in the same folder where my PBE application is. And then you click submit, and you can see that it's running the workflow up here. You will always get these messages to know what is happening. And now it's running the damage and loss calculations. And if all goes well, then you see the results. The results are at this RES tab, and there are two tabs within there. The data values, which plots you some of the data. I will go into more details in a second. And the summary that provides you, let me pull this a little bit, that provides you some statistics. So it gives you the mean, the standard deviation, and then a couple of percentiles, so that you have a general understanding of the marginal distributions of the different decision variables and some of the inputs here. So these are, for example, the time of the event. So not all of these things are decision variables. But for HAZUS, you see you have 4 different severities of injury. You have a reconstruction time, a reconstruction cost, and the number of inhabitants. And then you see how they are distributed in this particular meaningless example, because this was just a test, right? For the visualized part, we have a spreadsheet here. Each row is a realization. So you see we have, in this case, 1,000 realizations, and it shows each of those decision variables and inputs. And you can plot them against each other. So you can see the joint distribution. For example, we can plot, let's say, reconstruction cost and reconstruction time. Just to give you an example, there is this really neat way you can control what you plot by changing, by clicking on a column with the left or the right mouse button. So if you click on the, let's say, injuries, if I click with the left, injuries are put on the y-axis. If I click with the right, the injuries are put on the x-axis. So you can always plot two things against each other by clicking with either mouse button on them. Now, another thing you can do is you can click on the same column with the 2 mouse buttons, and then depending on which one was the last. So if you click with the right mouse button, the last, then you get a cumulative density function. If you click with the left, then you get a probability density function. So this one gives you, a general idea of the marginal distribution of this particular decision variable. All right, so this was interesting to see that the application actually works. But now let's put something together that is more meaningful. So we go back to the beginning and we say that this is going to be a 3-story building. So here we add 2 more stories. This is important for the loss assessment engine, so that it knows how many stories it needs to look at. And then we go to the simulation and increase the number of floors to 3. And as you can see, this is updated. So now we have a multi-degree of freedom system. And we don't want to simulate a 3-dimensional response. So we will increase the stiffness in this direction quite a bit. And we will add the hardening ratio of 1.0. So that means it's elastic, regardless of what the yield strength is. And I will update this with a couple of meaningful parameters, just to get some response that is interesting in the end. The story stiffness and the yield strength, and that's the last thing I need to change, I believe. And you can see that if you change these values, it will update all of the stories. So of course you could go and change it story by story. I just want to be quick this time. But if you do that, you can save your work. So it's not like you make a 20-story building and you do all these changes, and then the moment you close the application, you lose all that data. So whenever you feel like you already put a lot of inputs here and you would be sorry if they were lost, you just save what you did in a file and you will be able to load all those later. and I use 5% damping. Okay, so this should be it. So we have a 3-story building. It's a shear column. So it's not a really complicated thing, but it will be a good representation of, say, a shear wall structure. So we have stochastic ground motion now, but we would like to change this just so that you see something else. We use a peer, multiple peer option, which means that you can use peer format, ground motions defined in a peer format. I will add 3 of them now. And I prepared these earlier. So you go to, oh no, not here, that's coming. So we have events, and then I prepared a couple of ground motions that represent a 10% in 50-year event at Stanford, and I will load 3 of them now. And as you can see, this can be quite cumbersome if you want to load, say, 40 ground motions. So in the next example, I will show you how to do this quicker if you have a large number of ground motions. But for these 3, I think it's doable. So this just shows you how it works when you load the ground motions one by one. So we have 3 of them, and then I will specify the scale factors here, again by hand, but we have a way to do this automatically, as you will see in the next example. And yep, and we need to give some names to them. Usually I just use their IDs, so 68, 126, and 143. Okay, so we have 3 ground motions, and we want to run just regular OpenSeas analysis, but we don't need 10 samples, 3 samples is enough. This will make it a bit faster. And we no longer use the stochastic ground motion option, so we can remove this random variable. Okay, when it comes to the damage and loss, now we can say that we want to add some uncertainty here. Let me go into the details now for every step, for every field here. So for HAZUS, we have we give you the option to add uncertainty to the engineering demand parameters that come from a finite element analysis. One thing that you need to know about this HAZUS option is that this assumes that you have engineering demand parameters available from an analysis, and it uses the fragility and the loss curves from HAZUS. It does not use the curves that associate intensity measures with damage and losses. So it doesn't use the vulnerability functions, it uses the fragility functions. This is, I think, an important distinction. So it allows you to do a more sophisticated finite element analysis and still use the assembly-based fragility options in HAZUS. Now, given that we are only using 3 ground motions, I think the 0.2 is still quite bold here for uncertainty, but anyway, we just put some values here. These are added to the logarithmic standard deviation of the engineering demand parameters, so it adds uncertainty to the results. We will simulate 1,000 realizations. Here you could choose between different types of decision variables. If you don't want to, if you are not interested in injuries, for example, you could turn it off, and then that will make the calculations a little faster. Then we choose an occupancy type. It could be any of the ones that are available in HAZUS, and to make it easier for you, because probably you don't know by heart what this is, you can see a tooltip here. So you can choose the one that fits your particular building. And then now we will put more people because it's a 3-story building. Let's say that it's an office building. And this one, the building response part, describes your model, your building model and its response. And here we have the detection limits, which means you can specify certain limits. In this case, this is 15% drift, beyond which you don't trust your model. And this will be taken into account when we fit distribution to the engineering demand parameters. So even if your model produces a 20% drift, we will say that it is beyond 15%, so we don't really know what the actual drift is. And we fit a censored log normal distribution in the end. You could do that for floor acceleration, but I just happen to trust this model very much for floor acceleration, so I don't put anything here. And then damage and loss, I think replacement cost and replacement time are pretty self-explanatory. This is in dollars and this is in days. And then for the design information, this is again closely related to how HAZUS works. So you can choose a structure type. Again, you have the tooltips which help you. So we will say, whatever, we will say that this is a short steel frame. And then you can choose a design level, which will describe when it was built, and that kind of correlates with the strength and the capacity of the building. So we will say, I don't know, moderate code, or let's say low code. And here, this allows you to override the default fragility functions. So HAZUS provides some fragilities, as I mentioned, but if you have your own, you can format them according to the JSON formatting that we defined for the HAZUS, and I am very happy to discuss that. If you are interested in such things, it's not difficult. And then you can provide that here and override the HAZUS ones and make sure that the calculations are performed according to your fragilities. This is also interesting if you have a particular type of occupancy or structure that is not included in HAZUS and you want to do some calculations for that. Okay, so now we can run the calculation. Again, we can see that the simulation is running, the damage and loss calculations are running, and hopefully we see the results. There you go. So now we have results for a 3-story structure. Reconstruction cost is usually more interesting. And you can see, again, the cumulative distribution function or the PDF. You can plot reconstruction time versus cost. So you can have a general understanding of the data. And again, the summary results are available. Now let me move on to one more example, and that will be the last one, where we are not using this MDOF, but we are using a finite element model that was previously assembled by me, and it could be something that is assembled by you. Many of you probably use OpenSeas already, and you have your own models that might be much more sophisticated than an MDOF. And for this case, I will use a BRB, so a buckling restraint braced frame that I developed earlier, and I will show you how this exactly works. So just really quickly. So I have, this is the file that I loaded here. So you see this is the BRB FTCL file. And this code, as you can see, it references other TCL files, and it doesn't do much. It builds the model. It doesn't do the analysis. So this is a model file. If you went into the model builder, I will open the model builder for you just to see that this is a pretty complex model that is a good example of, I will just scroll into it just so that you see that there's a lot of things going on here. So this allows you, and this demonstrates that you can load anything here that is defined in OpenSeas and that will run properly in OpenSeas. So if you have your own model, but you have not developed a loss assessment tool that could estimate the damage and the losses to that particular building that you modeled, you can use our tool to load your model, do the analysis that you have been doing, and then extend it with a loss assessment step. One thing that you need to specify, and I think Frank also talked about this last week, is the column line. So this is a 3-story BRBF, so we have 4 points here because we need everything from the ground all the way to the top of the building. And because now we are going to use FEMA P58, we have to go here and specify a plan area. And I'm sorry, but I'm from Europe, so we are going to use standard units now. So we are using meters. This means it's 500 square meter. That's the plan area. And it's still a 3-story building. And although this was designed for Istanbul, we will put it in Stanford for now. We use the same 3 ground motions. I'm not going to change that. But for the analysis, these settings will make it very hard for the model to converge. So this again shows you something that I think is very nice. We can override those. So if you have your own dynamic analysis routine, and again, let me show you what that means. So I'm having a function. This is what I loaded, this tickle file. And I take the number of points and the DT value from the PBE backend. And I define the function to do the dynamic analysis here. It's an external function, but again, just to show you what that means, here is the function. So it's a fairly complex function that makes sure that we find convergence. Okay, so I loaded that will run in the background and override this one. For the uncertainty quantification, I use only 3 samples because these are more complex models and I don't want you to wait too long for them to run. And then for the damage and loss, we will go and use FEMA P58. Now, some of the general settings are familiar now that we talked about HAZUS a little bit. So you see that there is uncertainty quantification, same things. You can choose between decision variables. You can choose the type of occupancy and specify the number of inhabitants. For the building response, besides the detection limits, we can or you can specify a yield drift ratio. This is used for assessing the residual interstory drift. If you don't trust what comes from your model, you can estimate it based on the peak drifts. I don't know which one is better. It's your call. But if you want to do it, you can do it like this. You specify a yield drift ratio, and then we will make the estimation in Pelican. These are fairly straightforward. The irreparable residual drift, this is the limit beyond which you consider the building irreparable, even though it didn't collapse. This is quite important when it comes to losses. And then collapse limits are used to specify the limits in terms of interstory drift or floor acceleration that you consider collapse inducing. So if you have a peak interstory drift that is above 15%, then you consider the building collapsed. If you put a really high value here, you can turn off this feature, and then the building only collapses when you have no convergence in the analysis. Loss model dependencies allow you to specify many kinds of correlations between different parts of the stochastic loss model. This is for advanced users. I will not have time to go into the very details here, but what you can see just by looking at it, you can specify correlations between component quantities at different floors, different directions. As you can see, different performance groups. You can specify correlations between the fragilities of the components, between the reconstruction costs of the components or the reconstruction times, or between the cost and the time. So the same component, the reconstruction cost of the component and the reconstruction time of the component can be correlated. Injuries, or between different levels of injuries, and red tag probabilities, again, between different floors, directions, damage states, and so on. So this allows you to explore how those correlations influence the results and which correlations are important to consider, if they are important at all. And then finally, here we can choose the same kind of custom data sources. And we will actually do that for this example, because although I'm using the FEMA P58 fragilities, the ones that we ship with the tool are the ones that are provided in the FEMA P58 documentation, but many of those are missing some values. So what I did is that I defined I put some numbers to the undefined values so that we can actually calculate the losses properly, or at least we have a numerical value in the end. I will load an input file in a second, and then it will populate all these fields so that we don't take too much time there. But let's see the 2 other tabs before we move on. So there is a components tab, because this was only general settings. The components tab is where you specify the different components of the building. Now, by clicking the add button, you can add the new component, and you see that there are a couple of different pieces of information that you will need to put in here. Let me load the input file, and then we will see how this looks like. So this is how you would load a file that you saved before. Yeah, so this is how it looks like. Let me enlarge this a bit. Okay, so you see that we have different components for the building. This is the ID that is given to them in FEMA P58. These are the quantities on each floor. So the quantities are expressed in the unit that is provided or specified in FEMA P58. So this means we have 42 bolted shear tab connections on each of the 3 floors. This allows us to give some coefficient of variation. So if we want to have uncertainty in these quantities, it is possible with this distribution. And then these directions allow us to specify how many groups do we want to distribute these quantities to, and which direction each group corresponds to. So which EDP will decide the damage to this group. Now, there are a lot of directions here because I wanted to be very granular with these quantities, but if you look at, for example, this one, we have curtain walls, and I only have a 0 and a 1. So that means half of them, or 77% to be exact, because the weights describe that. So 77% will be in direction 0, and 23% will be in direction 1, and that's it. And you can see that you can specify if it's a structural component or a non-structural component. All right, so that's about the components. And then collapse modes, that's the final thing. We have complete collapse and partial collapse here with a probability. Of course, this has to be collectively exhaustive and mutually exclusive. And then we have an affected area. This means what proportion of the people in the building would die or get injured if the building collapses with a complete collapse, and the same thing for partial collapse. And this describes how many of them gets injured and how many of them dies. All right, so you could add a lot of additional collapse modes if you wanted to. And here you can see that we populated this with the fragility data folder, just to give you an idea how that looks like. So I have a folder here, and I see that probably you can see it now. So we are in this fragility data folder that I specified in the custom data sources. And I have these JSON files, and each JSON file describes one component's fragility and consequence functions. These are JSON formats that we defined so that they can support both the HAZUS style fragility calculation and the FEMA P58 style calculation. And just to give you an example of how one of those looks like, here is one for the buckling restraint brace. You can see that it is quite human readable, and it explains, it contains the same data that is available in PACT or SP3 or FEMA P58, because everybody uses the same things. All right, so now we have everything defined. Let me just make sure that I did not miss any of the important details. Okay, so let's run this locally. And I see that I only have 4 minutes until the hour. I'm sorry about that. If this runs, the last thing I will show you, and then I will open this up for questions, is that the same thing can be run with minimal effort through DesignSafe. And what we will do is I will start a calculation using 20 ground motions, which would take too much time for the webinar, but it will run in the background while we are doing the questions and answers session. And then I will show you how to grab them at the very end from DesignSafe and show the results there. So you see that it's still running the simulation. It's only 3 ground motions, but it takes more time to run such a nonlinear analysis for a real structure that is not just an MDOF stick model. In the meantime, to make good use of the time, I will also show you one thing. If you want to know more about the loss assessment part, you can go to GitHub. You see the address here. And in the NHERI SimCenter repo, you have Pelican, which is what we use for loss assessment. And this can be connected to your existing workflow, even without using the PBE backend or any of our applications. It's a Python package that you can load in and run a loss assessment with it. And there is a documentation. If you click to the docs here, it will take you there. And you can read this and get a better understanding of how this Python package works. All right, let's see how we are doing. Yes, so the calculation finished. So you see that now we have results for a 3-story buckling restraint braced frame that was designed outside of the PBE application, and the model was created outside, but it ran properly for 3 ground motions. And again, we see the reconstruction cost. And I don't know, we can make this joint distribution quite nicely, right? So it's much more interesting than HAZUS because it has more granularity when you run analysis with FEMA P58. Now, in the interest of time, I will only make one change here. I will load a directory. So you'll see we have 3 ground motions. If you have all the ground motions in the same directory collected, so you see that here in the events, I have this 10 in 50, which includes 20 ground motions and the special file that contains the scale factors for the ground motions. So if you select that, you see that it's populated with the 20 motions automatically. All of these, you might feel that I don't give you every piece of detail. The reason is that everything is explained in the manual, or it should be. So if it isn't, then tell us, and then I will append the necessary parts, but everything should be explained in the manual. So how to load these ground motions and how that works. So now we have 20 ground motions. We set the samples to 20, and instead of waiting 10 minutes for that, what we will do, keeping everything the same, is that we will run it at design safe. For that, you need to log into design safe, which is quite easy once you have an account there. Yeah, and then you give it a name. I give it a name. This is PBE webinar. And you see that we will get 20 processes running. One node is enough because each node has multiple processors. So this will mean that 20 of them will run in parallel. And usually you don't need that much time. Try to be very careful setting this max runtime because that decides how much you have to wait before your job actually runs. So if you know that it will run in 10 minutes, then don't ask for more than 10 minutes. And you don't need to modify anything below this. So all you need to do is submit. And you should see up here that it's creating the package to send to design safe, which is basically the input file, and then submits it and runs in the background. So you don't need to wait for it in front of the computer. You can close it once this disappears and come back later and get the results from design safe at that point. You see, it's already there. The job started. This is independent from this point, from your computer. I don't know what this green thing is. That might be math. So I think I will stop here. Our job is running. If I click on Get Design Safe, Get From Design Safe, you can see that it's pending, which means it's in the queue. It's the PBE webinar. And once it's run, we will be able to retrieve it and see the results. Now with 20 ground motions on a 3-story buckle and restraint braced frame. Okay, so I stop here. I'm sorry about running a bit over the hour. If you can stay here and if you are interested and want to ask questions, then please send them to Matt, and then I think he will relay them to me.
Yeah, thank you, Adam. Thank you very much. So if you have a question, you can send it in the chat window to the moderator, but we already have several questions lined up, and so I may encourage us to move to the Slack channel dedicated to the PBE application. and the Slack workspace, which is hosted by DesignSafe. If you have a DesignSafe account, you should have already access to the Slack workspace. And you can search for the PBE Applications channel. And we'll provide a link maybe in the chat window as well. But I know we're over time, Adam, but maybe there are just a couple of questions we could answer briefly before we conclude. And the first question is, I guess people are impressed with your PhD work. Is there an example or the example model that you demoed? Is that available to the community, or does it come packaged with the PBE application?
No, it doesn't come packaged with the application at the moment. If people are interested in this, like if I get a lot of feedback that people want to use this, I think we can probably package it with the application. But at the moment, it's available at my GitHub site or GitHub repo. So if you go to my place, I don't know, I think I can just so you go to GitHub, and basically you have to know my name, which is usually not easy, but you just put my name here, and it's right there. You can, oh, you see, it doesn't find me. Anyway, so if it happens to find me at one point, which is strange that it doesn't do it now. Oh, click on users while it tells me. Oh, got it. Okay, so that's me. And then you can see that among the repos, it's right here. Response simulation. And all the BRB models and everything is here. And I explain how to use it and everything. Okay, so if anyone is interested, they can find it here for the time being. And if I get a lot of interest, then I'm very happy to put it in the PBE tool and have it as an example there.
Okay. Another question, do you have a similar application for bridges, or are you looking to develop one for bridges?
Okay, so for bridges, if you want to assess the performance of a bridge, you can already have a bridge model loaded here. Now, the drifts are a bit challenging, but you can probably have the bottom of the pier and the top of the pier just to have a general idea about the bridge. What becomes really difficult is to come up with meaningful losses. And what you could do is the HAZUS technical manual already provides a method to assess losses for bridges. So you could use that method, define custom fragility functions, as I've shown here. So you just load a folder where you have those functions. You can do that, you know, if I switch to HAZUS, you can load it here. Those should be ones that correspond to the bridge that you want to look at. And then from that point on, Pelican doesn't really care if it's a bridge or a building. So if you have a proper finite element model and you have EDPs available, and then you have your own loss functions, then the workflow will work nicely for that, I guess. But if you are interested in doing something like that, send me an email and then we can talk. I can help you.
Okay. Is the application flexible to any choice of seismic intensity measure? For example, a function of spectral accelerations at different periods. So I guess this goes back to the fragilities that are available for the damage and loss.
Okay, so I'm not sure, Matt. It depends, because if I'm not sure what the person is interested in. If you want to use seismic intensity measures as the inputs for fragilities, then you need to do kind of a hack by making the intensity measures EDPs, and then those EDPs can be fed to Pelican, and then it will basically use fragility curves as if they were vulnerability functions. So that is possible. If you are asking about intensity measures for the event, then there, when you use ground motions that are previously selected. Of course, you can use any kind of intensity measures to do that. So that's not that interesting. But when you use a hazard-based event, for example, here we come up with a response spectrum and then do the record selection based on the spectrum. So if it's spectral accelerations that you're after, I think we can say that those are supported. If you are interested in more exotic intensity measures, such as SA average, for example, or duration, those are not yet supported, but we are very interested in those, and we would like to get them in as soon as possible if there is an interest from the research community. I think that's what I can say about that. Similarly, or I can give you a similar thing about for the losses. If there's an interest from a lot of people to have vulnerability functions available, so not only fragility, so go from intensity measures straight to damage and losses, I'm very happy to change the interface and make it available here. And then you don't need to do any kind of hacking in the future.
Okay. And another question, do you have ready functions in the model, impeding factors and repair?
I know. Not yet.
Okay.
This is a feature that we planned for the end of the summer. And I think I can say that we are working with the folks at ERAP to make sure that we implement it properly. I'm not sure it's going to be available by the end of the summer, but I think both parties are interested in this collaboration. So we will see when it gets done. We don't want to implement the old version that is 4 years old or something, but we are trying to work towards the newer one, but it's uncertain when this is going to get done. Let's just leave it at that. Okay.
Well, there are lots of other questions. I think I'll post those in the Slack workspace, the channels, the applications channel in the Slack workspace in order to kind of wrap up. I know we're over time. But,
okay.
And so we're at the conclusion of today's SimCenter webinar. On behalf of the attendees, thank you, Dr. Jarnotsai, for taking the time to introduce the PBE applications features and to answer our questions. To the attendees, thank you for your interests and your questions. If you have more questions, go to the Slack workspace hosted by DesignSafe and join the PBE applications channel. You can ask more questions there. And again, I'll post the questions that we ran out of time to answer this afternoon.
Matt?
Check the SimCenter's website at simcenter.designsafe-ci.org, where you can sign up to join the SimCenter's community newsletter, find out about upcoming webinars, events, and product releases. Thank you for attending today's webinar.